kind of go over what we've been experiencing, where we stand right now. So April wasn't so bad, but it still ended up in the top third warmest Aprils on record. Tucson and Phoenix were warmer than normal. Flagstaff and Winslow were about average temperatures for the month. Wilcox and Cochise County, Payson and Gila County, those were cooler than normal. We always appreciate that. And then looking at precipitation, there were actually three wetter systems in April, but the mid-April system was the most productive. You can see where the Little Colorado Basin looked wetter, and so did Jerome on Mingus Mountain. You're seeing it right there. Flagstaff had measurable snow the first half of April. That was the same as last year. Measurable snow, that's always great. For precipitation overall, Flagstaff ended at about 150% of normal. But it's important to remember that for Flagstaff, the normal amount of April precipitation is only 89 hundredths of an inch, not even an inch of precipitation. And that's because we start to move into April, May, and June. Those are the three driest months of the year. Tucson had better precipitation with the first system in April, but only ended with 5 hundredths of an inch of precipitation. Phoenix had 15 hundredths of an inch. That ended up being about 68% of normal amounts of precipitation for April. We'll take whatever we can get. Now we're going to take a look at water year reports, kind of where we stand for our water year. Remember that the water year starts October and ends in September. So we're looking here at the first 7 months, October to April. And we started just a review of what it looked like. October last year, we started October in the middle of a record-breaking heat wave. That's the one where Phoenix had the latest ever record of 113 degrees in October. October was the hottest October on record for the state. November seemed to be getting back to normal. There were several cooler but mostly dry systems that still allowed us to cool off a little bit. Then December started with a ridge that flattened and stayed in place with zonal flow. There were several maximum temperature records broken across the state. December ended up being the hottest December on record. January cooled off with a few systems, but not a lot of precipitation. Then February was back to ridging and a few drier systems. Thankfully, March and April were more active. So looking at that precipitation for the water year to date, October to April, after the heat wave broke, October was still mostly dry in our west, central, and southern counties. November was wetter for eastern counties. December was the second driest on record, and then January ended up being the fifth driest on record. February had one system that dropped precipitation, and that ended February as the 20th driest February on record. And then back to March and April, fortunately, had a few more wet systems each of those months. But I think it's important to understand, where we stand with our precipitation for the water year. Water year 2025, currently at 38% of long-term precipitation. That's running from October to April. This is the fourth driest October to April on record. It's also helpful to kind of explore what those first three driest October to Aprils look like. So those were water year 1904. That was the first driest October to April on record. The second driest October to April on record, water year 2002. And then the third driest, water year 2018. So kind of looking at all of this, water year 1904 and 2018, those both had wetter summers. Water year 2002 had a drier summer, and that ended with the driest water year on record. That was water year 2018. So even with a wet summer, water year 1904 and 2018, they both ended in the top 10 driest water years on record. Statistically, there's a very low probability that water year 2025 can even reach 100% of normal amounts for the water year. So looks like it's going to be another dry water year. we'll have to wait and see. But looking at what we had for our snow water equivalent, looking at the various basins, you can see that it was below median for most basins. Remember that December and January statistically have more winter precipitation than do February, March, and April. So when we're starting to look at these median amounts in March and April, take that into context. So let's take a look at the Verde Basin. They reached 114% of median amounts on April 19th. So even though that was a great amount, looking at statistically that amount, it was still only 0.8 inches of SWE. So we've been looking at one of the driest records for SWE this water year. And then looking at our short-term drought, certainly expanded after the very warm and dry conditions through February. That April precipitation, though, so even though it was very low, it helps to have precipitation in April because it's not a usual situation. And that helped mitigate some of the short-term drought. So really what we've seen happening here is a dry summer followed by a dry winter. And we did see that before. Summer 2020, winter 2021 definitely impacts our short-term drought. And then looking at that long-term drought certainly was impacted as well. So statewide, May 2024 to April 2025, that was the second hottest on record. The first hottest, May to April, was May 2017 to April 2018. Some of those numbers are probably sounding familiar. Statewide, May 2024 to April 2025, we had the second driest on record. The first driest, May to April, was May 2020 to April 2021. So it's definitely been hot and dry and impacting what's been going on with our drought conditions. I do want to bring this up. When we look at our CPC outlooks, we typically bring in the 8 to 14 day temperature and precipitation. The 18-14 day temperature outlook issued by the CPC is showing the potential for excessive heat coming up May 22nd to 28th. That is on Memorial Day weekend. I think it's important for folks to remember that outdoor activity after, some of these cooler temperatures that we've been experiencing, that outdoor activity can be more dangerous when there's a really rapid change in hotter temperatures. So heads up to everyone out there. And then this will be an interesting discussion because our guest speaker is going to start to move this forward to understand what's going on with the potential for our monsoon. I do want to let everyone know that next June for our webinar, we're bringing in Mike Crimmins, our usually chat as we get closer to the monsoon season, but we're really grateful to welcome Chelsea Peters for today's webinar, the warning coordination meteorologist for Tucson, Tucson has all of those great monsoon records and tools that can be used. So we're really, really grateful to have Chelsea come, and I'm going to go ahead and stop my screen and let Chelsea come on in. Thanks, Chelsea.
Thanks, Erin. It's great to be here with everyone. Let me just share my screen and we can get on going. All right. I think you're seeing it, so I'm going to press on here. Chelsea Peters, I'm the morning coordination meteorologist at the Tucson National Weather Service office. I did want to give a shout out to John Gluck, he's our climate program lead here at the office, and is the bulk of the data and everything that I'm going to share is actually comes from some internal things that was shared from John to the rest of the office. So yeah, want to make sure he gets credit for this. Okay, so just kind of what I'm going to go over, current conditions, which Erin covered extensively, so I'll probably breeze through those. But then diving a little bit deeper into some climatological correlations with looking at everything based on current and then uh, given all dry winters. So looking at those preseason, winter season precipitation correlations. Then briefly going over some climate models and then the CPC outlooks, and then ending it with that summary of everything. All right, so yeah, as Aaron had nicely already put, that a year ago, we were not in as dire of a situation in terms of drought. As of right now, where drought conditions across the state are attributed to about 80% including severe to exceptional drought, and there's about 25% of exceptional drought is covering the state. So very dry, as Aaron already said. So how did we get here? Again, the map on the left there is indicating the precipitation that occurred this past winter, and I'll show why that's relevant here in a minute. And then Aaron already showed the graph on the right there, which is the precipitation rankings for the water year through April. So it's lots of browns, a lot of area that had record driest. A good chunk of the state had their record driest winter last winter. So what does that mean? Or how did we get to that point? And the ENSO contributions that led us to that very dry winter. We were experiencing last winter with weak La Nina conditions that did eventually develop, which delivered on the forecast, which was that during La Nina conditions, we're typically favored to have those drier than normal conditions. So it was successful, and it very much verified for our area in terms of that. So looking at some climate correlations, so kind of digging into the weeds on answering this question, do the driest winters lead to a wetter than normal monsoon? So looking at a lot of this, and a lot of this is attributed to the Southeast Arizona Climate Division 7, but maps are for the state. So the data, though, is for that climate division region. So looking at the top 10 driest winters, the data produced about 6 or 60% of those resulted in top 15 wettest monsoons. And about 2 of those did end up being near normal monsoon. And then there is always that chance, right, that even if you have a dry winter, 2 of those years, 2 of those top driest winters did result in continued drought and produce below normal monsoons. So just digging in a little bit further, looking at the driest 25% of winters. So that's a total of 33 total winters. And looking at the corresponding following monsoon precipitation, there's about 60% led to the wettest monsoons. There's still around 30% resulted in near normal monsoons, and then the bottom about 20% continue with the driest monsoon. When you're just looking at, so the two-fold there, comparing all of those winters, so those 33 total winters, the driest 25% of winters, and comparing it to normal and getting that 2 category, it actually results in about 60% end up being above normal, so that's 7.31 normal number, and then about 40% ended up being below normal. So that's a good sign that both sets of data are kind of hinting that we're given a very dry winter, the top 25% of winters, the climate correlation is really leaning towards above normal. And then a note there is that 50% of some of the wettest monsoons for this climatological region resulted in over 10 inches during monsoon season after that, a very dry winter, which is pretty significant. And Yeah. Okay. So diving in a little bit more into we looked at the top, um, some of the top 5. What did I write here? um, the top 5 driest winters. 1999, 2000, 2006, and 2014 ranked in the top 10 wettest monsoons. So those 4 very dry, top 5 dry winters resulted in the top 10 wettest, and wanting to really dive into what did the actual composite monsoon ridge position look like during those seasons, and potentially would that be a glaring result in, or a potential solution for what ours set up in terms of ridge position, looking at those primary months, so July and August, could look like this summer, and what that could mean for Arizona. And essentially, the data shows here that the upper ridge mean position during these years are had slightly shifted north and east. So kind of opening up the doors when you're looking at that mean upper level height flow. We get that steady southeast and even easterly component winds that help drive moisture across, particularly southeast Arizona too. Okay, so kind of also looking at this, all these after dry winters and the corresponding CPC outlook that followed some of them. Those same ones that I was just alluding to, the 99, 2000, 2006, and 2014. But it's about a 50-50 split here. So following those very dry winters, the CPC outlooks produced either equal chances for a falling monsoon or above normal precipitation following a monsoon. So this is a little nugget to keep in the back of your head before we go into what the current CPC outlook is showing. So digging into some climate models, one of the big drivers in any climate model is those teleconnections. So ENSO here is that big one that everyone kind of knows about, and ENSO is really not a big influencer even in the summer, but sometimes can influence our tropical moisture that we may get, and may give us some leaning wetter or drier for the later half of the monsoon. That's really where that ENSO teleconnection factor comes into play. But given the current forecast and current conditions are neutral, there's not a big weight on any of the ENSO or teleconnections. Even the MJO is really not looking like it's going to be a significant factor in terms of influencing the climate pattern this summer. Okay, so some of the tools that CPC uses and looks at as of late for their latest update for the outlooks. It's kind of a mixed bag, but unfortunately it does look like some of their tools have been trending slightly drier or weaker with the monsoon signal. But that's not the case for all of them. So that's something to keep in mind. But a lot of these regions here are just highlighting maybe neutral or equal chances. But there are some indicators looking at that lagged average precipitation outlook that continue to support above normal for Arizona. And then looking at some statistical consolidation models that they produce too, there is some hints that, at least depending on the different leads here, so this is the June, July, August, there's a couple that are still hinting that there is above normal precipitation. But what's noted and what you'll see here coming up is that moisture looks like there could be a shift westward. So that's something that is then reflected in their latest update as well. And you can see that here in this upper right, the upper left, and then some of these, and then the bottom middle one and the bottom right as well, kind of hinting that there is a signal for above normal, but it looks like it is shifting a little bit further west given these tools. However, I always look at this one. This one's definitely the wettest of all the climate models that I was looking at, the CANSIPS model, and this is the precipitation anomaly and the June, July, August, so same time period of what we were just looking at the last two slides here, is very much screaming that, if the model could scream, that the precipitation anomalies are staying wet for a good chunk of the monsoon region, the whole Southwest as well. So that's interesting. But then when you dig down into the monthlies, it becomes a little bit more clear that it's leaning more on those first couple months that we typically think of as the monsoon, the July and the June, as being those maybe wetter months. So that kind of jumped out at me as well. And a lot of the models and the climate correlations that I didn't go over graphically, but the data kind of support an earlier start after following a very dry winter. And the climate models here, particularly this one, supports that finding as well, that it's kind of hinting that the moisture would be above normal for some of those earlier late June into July months. So it was an interesting correlation that we stumbled upon as well. Okay, so digging into the climate outlooks. So the monthly June update, and I was on the author that made this, and he put in equal chances because some of the reasonings there is they look at the soil moisture models, all of the things, but because some of their latest tools were backing off, they went with equal chances. There was some support when looking at the sea surface temperature composites to support a lean towards above normal, but they decided to go with equal chances, which is fair. So the precipitation outlook is calling for equal chances for the month of June. And then not surprising that we are expected to see at this point, the probabilities are pretty high, 50 to good chunk of 70% for eastern parts of the state on seeing those above normal temperatures. And a lot of the guidance supporting the temperature outlook for the month of June was really screaming the Southwest. There was overwhelming confidence that it was going to be above normal, and because of that, they really ramped up with that 70% category, which was something to note here. And then now looking at the June, July, August seasonal outlook, again, unsurprising for the temperatures they're calling for 50 to 60% chance there. That just tends to be the case. It's the new normal is above normal, right? Particularly for us here in the West and the Southwest. And then they do, after what I was showing with those statistical models and the things that the tools they use, was hinting at that westward shift with the above normal lean for this first June, July, August timeframe. So that's what's supported here and what they're indicating with this latest outlook being that first category of above normal lean shifting westward. And then the August, September, I think I skipped one. There we go. July, August, September, still highlighting much of the state as being above normal, 2 category up to about 50%, even for some of the central eastern parts of the state. Of seeing above normal precipitation. And then again, I think it kind of goes without saying that the new normal is above normal for temperatures, though it is noted that the likely lower category here during this time frame is attributed to the fact that we have more moisture around. So the increase in cloud cover could be in play here with this outlook. And then our final season and outlook update here is that August, September, October timeframe, just having the southeastern parts of the state holding on to that above normal for precipitation. Again, given the tropical ENSO influence is fairly negligible at this point, they just kept it and kind of highlighting the receding for the moisture receding during the later half of the monsoon. And then similar to last lead, 40 to 50% above normal across the state for temperatures. Okay, and then seasonal drought outlook. So even though given they are calling for good portions of the state to have above normal precipitation and it being warmer than normal, given the uncertainty with the monsoon precipitation, they continued with the outlook to say drought will likely persist, at least for now, but localized areas that do receive that beneficial precipitation from any monsoon storms would likely see drought improvement. They just weren't, the authors weren't confident on really showing that in this, at least this version of the seasonal outlook as of yet. Okay, so in summary, CPC outlook is favoring so 33 to 50% wetter monsoon, and then a warmer, so 40 to 70% above normal monsoon season or summer. Drought related and early monsoon impacts, kind of related to everything I just talked about. Typically, we usually coming off a very dry winter and going into a potentially active monsoon could lead to more dust storms, so more haboob development, things like that. That's definitely a concern that we have in our office of seeing that, at least for the first couple of storms, really kicking off some good dust, and given how drought prone we are right now, that would likely lead to some good dust storms at this point. And then since we don't really have a reprieve until those monsoons come, longer and more an active wildfire season, which we're kind of in the thick of right now, will likely persist. And then that seasonal drought outlook again is calling for drought to persist, but if the monsoon really produces some beneficial rain, areas would probably see some improvement. The data and correlations, looking at the Southeast Arizona area in particular, the data really is showing that 6 out of the 15 wettest monsoons occurred after the top 10 driest winters. And then of those, 7 of the 14 wettest monsoons that had over 10 inches of rainfall followed a very dry winter. And overall, monsoon following a very dry winter tends to be wetter than normal. So throwing a percentage on there, about 60% wetter than normal. And that monsoon ridge, just looking at a small set of data points there, could mean that it could shift and be slightly more north and east from the climatological position of around the Four Corners region. And if that is the case, then that again further supports the additional wetter than normal narrative of the monsoon, particularly for the southeast portions of the state. And then 3 of the earliest monsoon starts, so I didn't go over this, but 3 of the earliest monsoon starts, that 2000, 1967, and 1994 occurred after a dry winter. And that's again supported in some of the models saying that the monsoon could start a little bit earlier. And the climate model summary, the latest CPC guidance is indicating a weaker signal than previous months for monsoon precipitation in the past few months, but the overall message still stands that it is expected to be leaning above normal for the core monsoon months. And some of the June, July, August statistical models are showing that initially there could be a westward shift in the monsoon-related rainfall. But there's always a caveat of, there's always one model, right, that says that a more extreme scenarios could be at play, and that's going to be what I showed there, that hinting that the June, July timeframe could be a bit wetter than a lot of the guidance is indicating thus far. But all of this to say, the bottom line is that the climate outlooks do have skill in predicting those seasonal totals and averages in totality. However, monsoon precipitation is inherently localized. So areas may not experience significant rainfall, even if we do end up with above normal precipitation. And if that ends up being the case, that we don't get rainfall where we need it, which at this point is everywhere given the drought status, that would potentially lead to persistent droughts for those regions. But Arizona monsoon patterns, a note here that they can be realized within that 5 to 10 day forecast window, with our confidence increasing on timing and impacts within that 1 to 3 day time frame. And that's a general note there. But at the end of the day, all impacts will be highlighted and communicated through our messaging, partner email, if you're on our Slack channel, and through our social media accounts for public consumption as well. So highlighting any short-term impacts and changes in the forecast. And I think that's all I have. So unless, I don't know if you mentioned we'd take questions or not, but I'm going to end there.
All right, Chelsea, thank you for that excellent discussion. We really appreciate that.